Yes, good morning, students.
Good morning, sir.
So we will wait for 1 or 2 minutes so that other students also join. Then we will start. Okay. So now we have 41 participants. Can anyone just brief me what we have discussed in the last class? Yes, anyone? What we have did in the last class? Can anyone tell me? In the last class, we have finished your 3D modeling part of the syllabus. Okay, so till now we have finished your 4 units. One last unit is remaining, that is your solids in simple position and inclined to one of the axis. Okay, so let's begin. I'm going to share my slides. Yeah, I hope this one is visible to everyone.
Yes, sir.
So since I said that we are going to start with solids in simple position. So the first question that is coming to our mind is, what is solids? Can anyone tell me what is solids? Or you can try the definition of solid. Or as per your understanding, till now we have seen so many things. Yes, anyone? Can you define what is solid? At least you try. Okay.
A closed figure having some mass and density.
Very good. A closed figure having some mass. Okay. And the mass will come when you have some volume. Okay. So anything having volume that occupies certain space, that you can call it as a solid. Okay. So the thing is, in solid we have 3 dimensions: length, width, and your height. 3 dimensions. So you can see in your solids. So we have categorized, or solids can be categorized into two main categories that you can see on your screen. The first one is your polyhedra, and the second one is your solid of revolution. Okay, so In previous introductory classes also, I guess we have discussed about this polyhedra and solid of revolution. So once again, we will see about this. So let's see this. What is polyhedra? So a polyhedra is defined as a solid bounded by planes called faces, which meets in a straight line called axes. Suppose I will show you here. Yeah. This is a solid body, okay, bounded by planes. These surfaces are your planes, or also called as the faces, which meets in a straight line. They are meeting in a straight line. These are called as your axes. Okay. So polyhedra can be further classified into prism and pyramid. Okay. Now we will see what is prism and what is your pyramid. I will show you one example. So simple example, if you will see, uh, two faces you can see, square is there. On this side also one square is there. Okay, two parallel faces. Their corners are connected. Their corners are connected with straight lines. Okay, so you are getting a rectangular face. Okay, so four rectangular faces for this one. So this is your prism. So you can say a prism is a polyhedra having two equal and similar faces. Keep this in mind. Two equal. This is your square. This is the first face. This is your second face. Two equal and similar faces called its ends or bases. These are called as ends or base of the prism. Okay. Parallel to each other. Both of the squares are parallel to each other. This is square and this is square. They are parallel to each other and joined together by faces which are rectangles. So these square first face, this is your base square. This is connected by these rectangles. Okay. So this is called as your prism. Here you can see in the example, a triangular prism is shown here in this figure. So two triangles are there. This is your first triangle. And at the bottom, you have one more triangle. Both the faces are parallel and equal. Okay, equal also. And these two triangles are connected by the help of this rectangular face. I'm highlighting this for your better visibility. Rectangle also, I will give some other color. So this is your triangle in yellow color. This is your first face, and at the bottom also some part of the triangle. Okay, I will color it completely. So we have two triangles equal and parallel to each other. Okay, and they are connected through some rectangular face. Okay, so this type of solid is called as your prism. Now one more thing, as you can observe here in this figure, there is 2 points. This is your one point and this is your another point. These 2 points are nothing but the center location of the top and bottom faces. Okay, this is the center for this triangle, the upper triangle, or the upper face, or the upper portion, and this is the base or the lower triangle, and this is the center for your lower triangle. Okay, so these two centers are connected by a center line, as you can see here, a dot and small dash, a dot and small dash. This is your center line, representation of center line. I hope now it is well known to everyone. So this is your center line, and this center line is called as the axis of prism. Okay, so what is the axis of prism? The imaginary line. It is an imaginary line. It is not existing there. Okay, it is an imaginary line joining the centers of the base or faces is called the axis of prism. Okay, so this is a simple thing. I hope it is clear to all of you. So this is your prism. Now, as I have told you in this figure that we have two faces. Here, for the example, it is a triangle. The one I have shown you here, we have square, and similarly, I have few more examples. I will show you all of them. Yeah, if you are able to see my video, you can see here we have a rectangle. This is your triangle. This is your square. Okay, and we have one pentagon also. Okay, 5 sides like that. uh, you can have any number of sides, but you have to keep in the mind that they are equal and parallel. So here in this figure, if in the question it is asked that you have to draw the triangular prism, then this will be your drawing. This is your triangular prism. This is your square prism. As you can see, the top is a square, and the bottom, that is your base, is also a square. Okay, and they are connected by these rectangular faces. Similarly, you have this pentagonal prism. At the top you can see one pentagon is there. This is your pentagon top face, as well as at the bottom also, and the center points of both those top and bottom faces are connected by the center line that is representing the axis of that solid. Okay, so this is your pentagonal prism. And if you have a hexagon as your faces, top face and bottom face, hexagon means 6 sides that are parallel and equal, then you can call it as a hexagonal prism. Okay, so these figures I have shown you as an example, because when we will be solving some problems, like suppose we can ask question that pentagonal prism is resting on horizontal plane. Okay, suppose my hand, or this palm of my hand, is your horizontal plane, and you can see here this is a pentagonal prism. If that pentagonal prism is resting on HP, so you have to draw its top view and its front view, how it will look from the top and how it will look from the front. So you should know what are these triangular, square, pentagonal, and hexagonal prism, how it looks like. Okay, so this is about your prism. Now let's see pyramid. Pyramid, this is a polyhedra. Okay, as in the beginning only I have told you that solids we have classified into two categories: polyhedra and solid of revolution. Okay, again in solid of polyhedra we are breaking this into prism and pyramid. Okay, so pyramid, now we will see prism, we have seen in the previous slides. Okay, so what is pyramid? This is a polyhedra having plane surfaces as a base, okay, and a number of triangular faces meeting at a common point called as the vertex or apex. So as you can see, the base here is a triangle. This is your base, and all the corner points are joined together at a common point. This is your common point at the top. That common point is called as your vertex or apex. Okay, so again here also, uh, the imaginary line joining this vertex or apex with the center point of this base is called the axis of pyramid. Okay, so axis is common to both the surface, both the polyhedra solids, that is your prism and pyramid. Axis is nothing but the imaginary line joining the center point of the base to the apex or vertex for pyramid, or for the case of prism, joining the center of your top surface and the bottom surface. That is your axis of the polyhedra solids. Again here, if the base is triangle, as you can see here, if the base is triangle, it is called as triangular pyramid. If the base is square, as you can see here in this diagram, the base you have here is a square. So this is a square pyramid. If the base is pentagon, means 5 sides at the base you have, then it is called as your pentagonal pyramid. And if you have 6 sides, then it is your hexagonal pyramid. Okay, so all of you please pay attention, because this is the last unit that we are going to cover. Once again, I am telling you, if you will see your syllabus, I will show you your syllabus. Yeah, I hope the syllabus is visible to all of you. And we have completed your unit number 1, 2, and 3. In unit number 1, you have introduction to your computer aided drafting. In unit number 2, you have 3D modeling and 3D modeling tools. In unit number 3, you have conversion of pictorial views from orthographic to isometric and vice versa. And now we are looking for your unit number 4, that is projection of solid. In projection of solid, we will see different types of solids, projections of solid in simple position, projections of solid with inclined, axis inclined to one of the reference plane and parallel to the other. Okay, so in this unit number 4, we have 3 things: types of solid, projection of solid in simple position, and projection of solid with axis inclined to one reference plane and parallel to the other. This is your unit number 4. And you all know that unit 5 is nothing but your project work. That will be a teamwork. Okay, so whatever you have learned in these 4 units, using those skills, you have to work on some project. Okay, so today is 29th of January, and I guess from next week or 3rd of February, your physical classes may start. Okay, so when you will come to the lab, you can practice whatever we have studied during these classes. All the recorded videos I have uploaded to your canvas. So slowly by slowly, you can revise all those things. Before coming to the class, you must see any one of the, like, if you pick this unit number 3, that is conversion of pictorials from orthographic to isometric. So you must go through that video, you must revise it, okay, before coming to the lab sessions, so that you can directly come and practice here. Okay, anyhow, if you face any problem, I will be there to help you. So let's focus on our unit number 4 for today's class. So this, you can say that this is the last theory class, okay, because by this we will finish almost around 80% of the syllabus. Remaining 20% is your project work. Okay, so coming back to my PowerPoint slides, yeah, we have seen here solids having 3 dimensions, that is your length, width, and height. Then we have categorized solids into 2 categories. The first one is your polyhedra, and the second one is your solid of revolution. Okay, we have seen 2 categories of solid: polyhedra and solids of revolution. In polyhedra, again, we have divided it into prism and pyramid. Just now we have seen prism. Prism is nothing but we have two equal and parallel faces connected by rectangular faces. Keep this in mind. In prism, the connecting face is a rectangle, okay, whereas in the case of your pyramid, the connecting face is triangle, okay. So a pyramid is having the base of triangle or square or pentagon, okay. So their corners are coming to a common point, that is your vertex or apex. So this is your pyramid. We have also seen different types of pyramid like triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. Basically, it is depending on the shape of the base. If it is a hexagon, then you will call it as a hexagonal pyramid. Okay. So this is all about your polyhedra solids. Now coming to solids of revolution. Okay. When a solid is generated by revolution of a plane figure about a fixed line, then such solid is called as solid of revolution. Okay. Now, for example, I will show you here. Suppose you have a right angle triangle. Okay. And you can consider this side as the axis of revolution. And if you revolve this right angle triangle about this axis, then what you will get? Anyone? If you will revolve this right angle triangle about one axis line, what you will get?
Cone.
You will get a cone. Okay.
Cone.
Yes. Similarly, suppose we have one rectangle. First, I will draw the axis line, and you have one rectangle. Okay, this is a rectangle. Let me give some yellow color. Okay, and this is your axis. Now, if you revolve this rectangle about this axis line, what you will get? You will get a
Cylinder.
cylinder. You will get a cylinder. Okay, so suppose one more case, if we will take, suppose you have a semicircle, and let me draw the axis line. Suppose this is your axis line, and now we have a semicircle, and if you will revolve this semicircle about your axis line, what you will get?
Circle.
Sphere.
Circle.
You will get a sphere.
Yes, sir.
Sphere.
Yeah, this box
3D
you
కదా.
can see here. This is sphere you will get. Okay. So here we have seen that in solid of revolution, you are having two things. Two things are required. Please mute yourself. Okay. So here we have seen that in solid of revolution, we need two things. One profile that we are going to revolve, okay, that we have seen in your AutoCAD commands also, and one axis about which you are going to revolve. So if we have a right angle triangle, as we have seen for your first case, okay, when you are going to revolve your right angle triangle, you will get a cone. When you are going to revolve this rectangle, then you will get a cylinder. When you are going to revolve this semicircle about one axis, then you will get a sphere.
Sphere.
So yeah, so for solid of revolution, you can see here, when a solid is generated by revolutions of plane figure about a fixed line, that is axis, then such solids are named as solids of revolution. Okay, so here we are considering two portions, because the problems that we are going to solve will be from cylinder and your cone. Okay, so this is your cylinder. You all know that you will be having two circles, one as the base and one as the top surface, and there will be connecting rectangles, as you can see here, because you are revolving one rectangle to get this cylinder. Similarly, here you can see a right angle triangle, and that right angle triangle is revolved about an axis to get this cone. Okay, so anything else important terms used in projection? Yeah, in projection of solid, you all know that we need to have generators. This is one term, generator. That is nothing but these these lines that you can see, which are connecting the corner or the apex or the vertex to your base. That is called as your generator. And axis is your center line, and this one is your base. Okay, so based on this, we can solve some problem like you have seen in your syllabus, objects in simple position. Okay, so I will show you on your AutoCAD software now how to draw solids in simple position. I will share another screen. Yeah. Now you can see your AutoCAD interface here. I will tell you the problem statement. I will write here using annotation. I will write here. Okay, now I hope this AutoCAD screen is visible to all of you. The statement that I will write here that you can note down. Draw the projection of square prism. I will make it capital. Resting on HP. HP stands for horizontal plane. So in short, we used to write HP, horizontal plane, about its one of the base. The space key is not working properly for this keyboard. On one of its base. Okay, the base edge length is given is of 20 mm, and height of the solid is 70 mm and one of the base edge is perpendicular to vertical plane. So this is the problem statement. We will see six problems here. Okay, six simple position or simple problem, and then we will solve one problem where the object is inclined to one of the axis. Okay, so this is a square prism. Okay, and what are the informations here we have given that we will write first. So let me use annotations. So here you can see the informations. It is square prism, okay, resting on a horizontal plane. This is another point. About one of its base length is given your 20 mm, its height is given 70 mm, and one of its base edge is perpendicular to the vertical plane. This you have to keep in your mind. Then we will go to the top view, as this is your 2D representation. So we will stick on one plane, that is your XY plane. Okay. Now we need to draw your reference line. So first take a line segment, put your ortho mode on, and take a line. I'm taking of length 100. Okay, then you can use zoom command, Z enter, A enter. So this is our reference line. Whenever you are using this reference line, mention X and Y on both the sides. So you can use the text command, specify a starting point. Text height we will keep as 6, or you can keep it as 8. Orientation angle 0, fine. Let's type on reference line, one side we need X, another side we need Y. Okay. So it is a very big size, so you can even reduce it. Where is the text height? Make it 5. 5 is still looking bigger, so you can even make it smaller. 4, 3. Okay. Similarly on this side also, select the object wherever you have to do any properties manipulation. You can select that object, right click it, go to properties, and here you will get height. You can make it of the same height what you have done there. Then you can move it to your required position. So now you have your reference line is ready. Okay. After this, as the question is saying that it is a square prism and it is resting on horizontal plane. Okay. So if you will see in the video, I will show you the video. Yeah. This is your square prism, square first side, square second side. Both are equal and parallel to each other, equal and parallel to each other. Okay. And they are connected by rectangular faces. So this is your square prism. Now, as per the question statement, it is resting on horizontal plane. Suppose this hand is your horizontal plane. I have told you in the introduction classes that this is our horizontal plane, and this face will be your vertical plane. Okay, this face will be your vertical plane. So this square prism is resting on your horizontal plane. So if you have to see its true shape, okay, in your top view, what you will see? In your top view, you will see this
Square
rectangle.
face. Ah, square.
This is square. This square you will see on the top view. Okay. And in the front view, what you will see? In the front view, you will be able to see
Rectangular.
this rectangular face. So first we will draw those two positions. Okay. So the dimension of that rectangle is given. The dimension of that square prism is base length is 20 mm. So you can pick directly a rectangle, or you can start with your line also. As I have told you that in your top view, you will be able to see a square. So let's start. Put ortho on. In this direction, we need to move 20. Upper direction again 20. This side 20, and you can close it. So this is your top view. Okay. Below the reference line, what you will get is your top view. I will move it for better visibility. I'll keep it in the center like this. Okay. Okay, now this is looking good. Now the question is, suppose we have two squares, upper face and the bottom face. If we will give names like A, B, C, and D to one of the face, A, B, C, and D, and for other square, we can give numbers 1, 2, 3, 4. If the object is lying on your horizontal plane, okay, so both the corners, A and the bottom corner, this, suppose this side, this corner and this corner, they will overlap. So if you have given the names like ABCD, and for the bottom square 1 2 3 4, so this two will be overlapping. So we will give the names, and here overlapping ABCD and 1 2 3 4 will come. So I'm directly copying this X alphabet from there, and then I will edit it. So here we will be having A, comma 1. We are having here two corners because we are looking it from the top, and two corners are overlapping on each other. Okay. Similarly, you can copy this, Control C and Control V. Here we will be having two corners again, B, comma 2. C, comma 3, and here we will be having D, comma 4. And again, as I have told you that there will be center point of both the faces. Okay. And connecting those two center points will give you the axis. Okay. So once again, there will be one center point and they are overlapping on each other. So at the center of this square, you can keep uh, you can keep O and O dash, or you can write O or O1. Okay, representing the center point of top and the bottom face. Okay, now we will draw the projection lines from all the corner points. Switch on the ortho. Okay, one more projection line I need. In the previous examples for drawing the projection lines, we have taken X line. X line is nothing but the line of infinite length. So that also you can take, okay? So let's take that only because I'm drawing the projection line. The command is X line, you can see in the command line here. We need vertical, so you can click on this VER and you can place it at this point and at this point. Okay, so X line I have used to draw a line of infinite length that is representing here your projection lines. Keep this in your mind. Okay, now the height of the solid is given 70 mm. Height of the solid is 70 mm. So the upper face will be somewhat at a distance of 70 mm. So you can use offset command. Offset distance, let's keep it as 70. The object is your this one on this side. Okay. Now you can trim the unwanted portions. For that, type the command trim in the command line and press enter 2 times. Then you can click on the unwanted portions that you want to delete. Okay. Okay. Now here, if you'll see this line is coming up to here, you can reduce it at this location and you can reduce its length up to this location only. Okay. Now, this is the height of the prism, but it is above this reference line only. But when we are selecting this, entire line is being selected. So there is one command called break. Let's see how it is working and where we want to break this line at this point. Okay. Now you can check. These are two different entities. Okay. Similarly, you can break this line also. Select this as object where you want to break. You want to break here. Okay. Why it is shortening? Let's close this. And you can change the color of your projection lines. Go to right click, properties, and color you can change for your projection lines. Any color you can select. Okay. Now, if you want to show your center line also, that also you can represent. Go for the line command. At the middle location, you can see here when you will bring your cursor, a small green color triangle is coming over there. So from there you can start up to this location. You will get one up to this point. This is your center line or the axis of this prism. So since it is the axis, so it cannot be continuous line. You have to change it. You have to change the line type to center line. It is not here. So I who is this?
Class.
Please mute yourself. Okay. So if I want to load here the center line, so the command is line type. Go to line type. Here you will see load option is there. Go to the load and you can select the center line over here. Yeah, this is your center line. Click on OK. Again OK. Now select the line. Go to properties. Line type. Now center line is coming here. You can see how it is looking. If you want to scale it up, you can select, go to properties and line type scale is 1 here. You can increase it to 2, or you can increase it further to 3 for better visibility, or 4. Just by visual, you can see here whether it is looking properly or not. So likewise, you can give the names for this location also. Now that we all know that the one square, we have two square, one the top surface and one the bottom surface. Okay, so the bottom surface square that will come here, that we can consider as ABCD. So let's copy this and paste it at this location, and this will be now at this point we will be able to see A and D. So we will write A prime comma D prime. Okay, so you can place it as per your choice here. Similarly, at this location, at this position, you will be able to see corner B and corner C. Okay, so let's edit it. C prime comma first B, B prime comma C prime. Okay, so these are the corners that will be visible at your front view. Similarly, you can give the name to this axis point also. Here you will be having only one center. So let's make it as O1, or only O. At the top, you can keep it as O1. Okay. So for that difference, that this is your top view, in top view we are using the nomenclature A, whereas the same point I am using A prime in your front view. Okay, so this will give you a clear information that this is your top view and this is your front view. Different notations are used. Keep this in your mind. Okay, now in the same way you can keep here also. What are the corner points that will be visible here? 1 prime comma 4 prime. Similarly, at this location, you will see 2 prime comma 3 prime. And this center point, for the center point also we will write something. O1 we will use, and 1 prime will be representing that it is front view. So this O prime and O1 prime, it will be overlapping at this center location. Okay, so if you wish, you can draw the center point also, but anyhow that point, do we have any option to specify the point? So here we can have one point. I have drawn here one small dot, you can see. Okay, this is our point. So at that location, you can copy this, Control C and Control V. Here we are having 2 points, O comma O1 at this location. You can move it as per your requirement. Yeah. So this is your center location, and this is how, what is the solution for the problem statement that we have seen on the top. This is the projection for a square prism resting on horizontal plane about its base, and the base edge is 20 mm and the height of the solid is 70 mm, and one of the base edge is perpendicular to the vertical plane. Okay, so If in the examination this question is asked, then you have to do its solution like this. I hope it is clear to all of you, as this is a very simple problem. If it is clear to all of you, type in the chat box, clear sir. If you have any doubt, you can ask me. Okay, good to see your responses. Uh, Now we will take a short break of 10 minutes, and after 10 minutes, again, we will start the class. Yeah, students, I'm back. So here we have seen one problem related to your square prism. One thing we have left doing here, that you have to give the dimensions also. So go for dimensions. Where is dimension? Okay, if you are not able to find the dimension option there, you can go with the command line dimensions. Okay, we need to give normal dimensions, or you can go with the aligned one. Okay, so for no, it's not working. We have to bring back our dimension here. If horizontal vertical, we can give it from here. Go for dim, and if you have to give horizontal, then you can write HOR. You can select those points. Okay, and similarly, if you have to give vertical commands, then you can write VER, that is your vertical dimensions. You can give it here. Similarly, I want to give vertical dimensions of, I'm showing you all possible options that can be used. Earlier, we have done it using your option available there. Now, as you can see here, the text of that dimension is very, very small, and that is not properly visible. So again, for that, we need to go to dim style. For going to dim style, first we have to come out of this portion, dim style. Okay, go to modify. You can change the color of your dimension line. Okay, line type will be continuous. Extension line also we will make it green. Arrow size we will make it as 3. Text height we can increase. Let's make it 5. Horizontal aligned with dimension line also we can do it. Then precision you can make it 0. Click on OK and then close. So automatically you can see here whatever the dimensions we have given here, now it is clearly visible. As per your choice, you can move those dimension lines so that it will not overlap on each other. So this is your first problem statement. Likewise, we will see few more problems. For that, I am taking a new tab. Okay. And for this, now I need to erase this annotation. Then only I can write the new problem statement. I will write here. Okay. Now let me see what is the problem statement. Yes, any issue? Now this time we have a pentagonal prism. So I will write here draw the projection of pentagonal prism this time. Pentagonal prism of 20 mm base edge and 70 mm height. It is resting on your horizontal plane. So I am writing HP, that is representing your horizontal plane. On one of its base, and one more condition is given, one of the base edges is perpendicular to the vertical plane. So for vertical plane, I am writing VP. Okay. Draw the projection of pentagonal prism of 20 mm base edge and 70 mm height resting on horizontal plane on one of its base, and one of the base edge is perpendicular to the vertical plane. Okay. So now we will see this question. So the informations, what are those informations that we will highlight? First information is, it is, oh, sorry, a pentagonal prism. Base length is 20 mm, height is 70 mm. It is resting on HP on one of its base. Okay, on one of its base, and one of its base edge is perpendicular to your vertical plane. Okay, so you can draw first rough that how you are going to draw it. So since it is resting on a horizontal plane, suppose this is your reference line XY, and it is a pentagonal prism. Okay, and one of the base edge is perpendicular to VP. So we will make one line that is perpendicular to this vertical line, reference line. Then you can draw one pentagon, 5 sides, 1, 2, 3, 4, and 5. After this, you need to draw the projection lines for all the points. Okay, so since we have considered this perpendicular, freehand I am drawing, so maybe it is not exactly what. So these two lines will come overlapping each other, and again this will be like this. So we will get something like this. When we will draw as per the scale, it is showing some inclination. Pardon me for this. These are perpendicular lines. Okay. So now we will draw this using your AutoCAD. Okay. Close the annotation. Take your reference line. You can copy it from the previous one. I'm going to copy this reference line and pasting it over here. Zoom Z, enter, A, enter. Okay. So this is your reference line. Now we need to draw a pentagon. Okay. So you can use this command polygon. Number of sides 5. Specify the center of the polygon. Suppose this is yours. This is the location where I want to draw. Okay, it is asking for inscribed a circle or circumscribed a circle. So better we go and draw with, because we don't know what will be the diameter of this. And suppose if I am taking circumscribed, then again, okay, let's see whether we are getting that value or not. 20. Okay, now let's check the dimension for this. It is coming 29. So that is incorrect. So I will delete this one. We have to draw of side length 20 mm. So let's go with line command. We will first draw a vertical line, and on downside it should come 20, and from here we need to draw some angle. Do you know the inside angle of your pentagon? What will be the inside angle of your pentagon? As I guess it should be 108. Let me cross check. There is some formula. If you remember that, you can tell me. 108 is the included angle of your pentagon. Okay, let's come back to our drawing. So if we want to draw an angle that is 108, so 90 minus 108, it will be 18 degrees in negative direction, and the length we want to move 20. So at the rate 20, and angle is your uh, minus 18. Let's see whether it is working or not. Yeah, it has worked. Then again from here, or we can come from that side also. So what will be the new angle if this is 108? I want to draw. Let us do some calculation. If this is your horizontal line, we know that this is your 18, this is your 108. So what will be this value? Can anyone tell me? 180 degree minus 108 minus 18. So you will get 180 minus 126. How much it will come?
54. 54.
54. Very good. Okay. So let me close this annotation. Eraser. Okay. Now at the rate, length is 20 and angle is 54. Okay. Again, what will be the new angle? You can come from this side or you can start from this side. You have to do the angle calculation. Start from this side. If we want included angle as 108, so 90 we can minus. So again we will get 18 degrees. Length is 20. Angle is 18. And then you can join it. So this is the pentagon that we have drawn. Now you can check its dimension, whether we are correct or not. 20. You can see here. You can change the dim style. Modify this. Color you can change. Text height we can keep as 5. Precision 0. Okay, close. Okay, so this is 20. Now the next step is drawing the projection lines. For projection lines, we are using X line. X line is the line with infinite length. From all the vertices, you can take the projection lines Okay. After this, you can change the color. Go to properties and color is by layer. You can change it as per your choice. Keep it some light color. Okay. Now the height is 70 mm. So I will do the offset of this line. Offset distance is 70. Object is this on this side. Use trim command, double enter, and unwanted lines you can delete from here. Okay. Now these lines you can bring it up to your required locations. Okay, this is fine. Now you can break these lines at these points. You can drag it and bring it up to here. You can drag it and bring it up to this point. You can drag it and bring it up to this point. Now, this I have broken because I want to make this as my regular lines. So we can change the color. Go to quick properties and this light blue color, you can make it to by layer. So it is in white in color. You can cut or you can shorten this. I will use this trim command. Cut this portion as well as this portion. Okay. Now the next thing is our center line, where our center line will be lying. Okay. So that you have to find out. So suppose your center line is passing from this location. Okay, wherever the perpendicular bisector of these two lines will intersect, that will be the point of your center line. Okay, so roughly I am taking considering at this is the point where go for the command point, or you can take the midpoint also for this one. That is also one of the good idea. I'm taking the command line starting from the midpoint of this one up. You will take perpendicular lines, so keep ortho on. Okay, and it will suppose come up to this location, the perpendicular bisector of this one. Okay, that also we can identify. Okay, I will show you how to do that. For here you get this midpoint. Now on this side I want to identify the midpoint of this one. So yeah, this is your midpoint and this is your intersection point, like this. You can pay attention how I have obtained this point. I have started from this midpoint and I need to come up to the midpoint of this location. So get the midpoint location of this line and you can get a cross mark at this location. Yeah. After this, you need to change the line type, right click, properties. If here you are able to get the center line, then that is fine. If you are not able to get that center line, go to the command line type, load that line which you are looking for, that is your center line. Okay, right click, properties, go to line type, make it center, and scale you can increase for better visibility. See, I had made here 5 and its reflection you can see between the distance between the smaller dash and the bigger dash. You can see it's, if I'll make it 3, then how it is looking. If you are making it 5, how it is looking. So better to keep 5. Okay. Now the next thing that is remaining is you can give the dimension for this portion also, the height portion. Let's give it dimension. I want to give vertical dimension. We know that the height of this prism is 70. Okay. After this, you have to give the namings. Okay. Namings like in the previous, I have shown you. Once again, I will show you. Don't worry. Yeah. On my hand, you can see I have a prism. I have a prism over here in my hand.
Okay.
Okay, so you can see we have two pentagons. This is the first face and this is your second face. So if it is lying on your horizontal plane, then the corner points will be overlapping. So if for the upper pentagon you are giving A, B, C, D, E, so the bottom portion you can give 1, 2, 3, 4, 5. Okay. So likewise, we will give the nomenclature that we have given in the previous figure. So we can copy this and you can paste it over here. I'm pasting all those points and then we will rename it. Okay. Okay. So here A and 1, here it will be B comma 2, C comma 3, D comma 4, E comma 5. Okay. Similarly, at these locations also, here you will get O and O1, O comma O1 you will get. Okay. And this line segment that you will get it from here. Let me take one more line. Yeah. For this line, here we have two lines. Actually, that is a pentagon. Okay. Front view of a pentagon. So here we are getting, here we will be able to see A prime comma E prime. Let us move this little bit on this side. Similarly, at this point, we will be able to see only one point, that is your C prime. And at this location, you will be able to see B prime comma D prime. Okay. So this is that point. Similarly, in the same way, you can give the nomenclature at the upper location also. This is your 1 prime and 5 prime. Please mute yourself. Here you will get 3 prime, 2 prime, comma, 4 prime. Okay. Similarly, here you will be having O prime. Okay. And at the top, you will be having O1 prime. Okay, so once you have done with this part, then you can write your name and roll number, and you can take the printout. Okay, so let's do it fast. You have to go for the text command to specify the first point. Suppose I want to write it here. Text height I will keep as 5, rotation is 0. So we can write a roll number 1, 2, 3, 4, 5, and you can also write your name. Suppose XYZ. Okay. So once you have written your roll number and name, and also you can write problem number or exercise. This is our problem number 2 of unit number 4. This is the problem number 2. So you can write like this. Okay. So once you have done your writing part, then you can print it, Control P, select your printer, go to your A4 page paper, window you want to plot, center the plot, and then click on preview. So this is what you will get. Let me clear the annotation. Yeah. So this is what you will get in your printout. This printout you have to take and you have to keep it in your record book. Okay. So once you will come to the college and you will do its practice and you will plot these things, then you can take the printout and you can keep inside your record book. Okay. So you can save this file, save all the file at one location. Okay. As I have told you earlier also, keep all your files in one portion at one location. This is our, we can write here as unit 4 exercise problem 2. Click on save. Similarly, you can save the previous file also. Drawing number 1 also you can save it. From here, I will copy your roll number and different details, and you can paste it at this location. Only thing we need to edit this one is your exercise problem for 1. Okay, then Command P, go for printing, go to this AutoCAD PDF, A4 size paper. What you want to plot, select the window, and this will be your window. Center the plot, preview, and this is what you will get as your exercise number 1. Then save it, give the name, and here make it as exercise problem 1, and then click on save. This is your first problem. 2 problems we have solved. Now let's move on to the third problem. First, I will write the problem statement on your screen. One simple problem now I am giving to you. Suppose I will ask you that you have a cone. You have a cone whose base circle is having diameter 20 mm, and the height of this cone, okay, height of this cone is 70 mm. So this is one problem related to your solid of revolution. And for other problem, we can say that this is a cylinder. The cylinder, the radius or the diameter of this circle is 20 and the height is 70 mm. So you can draw those two things in a single slide. Let's move on to the solution direct. No need to write this. Or if I have to write, I will write draw the projection of cone and cylinder having base diameter 20 mm and height 70 mm. Okay, draw the projection of cone and cylinder having base diameter 20 mm, height 70 mm, uh, comma, it is resting on horizontal plane. Okay, so this is the simple problem statement. Okay, you have to, both the figures I will draw here in the same figure. So first we will need a reference line that we can bring it from our previous problem. For multiple selection, always remember shift is the key that you need to press, then control V. Yeah, so this is your reference line, and as I have told you that the base is having a circle of diameter 20 mm for both the case. So here I am drawing both the drawings. Diameter specify the radius is 10. Okay, so this is the cone portion. Suppose now we need to draw vertical line. This I am drawing for your projection lines, and one more I need for your axis line, and that will be again a vertical starting from its center point. Okay, now change the color. The next step is changing the color of your projection lines. Right click, go to properties, change the color to some light color. Okay, close it. Line type command you have to use to bring your center line. Okay, now change this line type to center line. You can change its line type weight. Now we have obtained here the center line, and you need to offset this at a distance of 70 this object on this side.
Trim.
Yes, after this we need to do trim. So remove all the unwanted lines that you don't need. Okay. Anyhow, we don't need this also because this is a cone. Okay. I will remove this side also. Okay. Now take a line starting from this point and going up to this point. From here you join it at this location, and from here you can drop to here. So this is the front view and the top view projection of a cone with base diameter 20 mm and height is your 70 mm. Okay, similar kind of thing is there for cylinder also. So I am taking that same at this location also. Go for multiple selection. We need these things. Control V. No. Select these lines. This circle also I need. This also I need. Copy. Okay. And then paste. No, it is not coming. Okay. Go for copy. Base point, suppose I am taking the center location, and you can move it up to this location. Okay. Okay. Now, since this is cylinder, I am bringing two problems on this single slide. So you can start it from here and it will go up to here. In this direction, you can move distance of 20 and then come back and close the figure. Now you need to give its notations again. So for giving the notations, you need to have generators. Okay. So again in vertical direction also. Okay. In the same way, we can draw the projection for these lines also. Okay. Now you can give the names. The same font size, for same font size, we can copy this. Control C, coming to our drawing number 3, Control V. Suppose this you are keeping as A. So on this side, it will be B. Okay, here you will get O. Okay, so its projection here it will come as A prime, and at this location you will get B prime. Here we will be having 2 points, O comma O1 I will write. Okay, here one of that point will come, that is, suppose here it is coming O prime. So here it will come. This is the topmost point, that is your O1 prime. Okay. In similar way, you can give notations for here also. So we can copy this also because most of them will remain the same. So this will also be the same. This is also remain the same. You can copy this. Okay. And base point, you can keep this center location and you can bring it to this location. See how I have done that. To save the time, you can use different tools. Okay, so here now we will be having A comma 1, and at this location we will be having B comma 2. A prime, B prime, O1, O dash. Now here come at the top, copy any one of them, and here it will be your 1 prime, and on this side you will get 2 prime. Okay, so 1 prime, 2 prime, A prime, B prime, all the point here O1 will come, here O1 prime will come, O1 prime will come into the picture. Yeah, everything we have done. Now the dimensions you can give. Suppose you want to give vertical. So this is the location point 2, and this is what you will get. It is looking very small, so you all know what you have to do. You have to do the dim style, go to modify. Now I will go a little bit fast for this portion because you are observing these things again and again. So this is your 3. Text height, I will keep it as 5. primary unit is 0. Okay, and close. Okay, so this is your 70. Since we are using this same line, so you can delete this and you can move this little bit above. You can move this little bit above for better visibility. Okay, so this is one way, and you can show the height of this portion also. From here up to here, this is your 70 that you can show. Okay, they are intersecting, so you can move it little bit, switch off the ortho. Okay, O1 prime. Now the diameter you can show in the top view. Okay, the diameter you can show here. This is 520 for the circle, and for this one also you can give the diameter, press enter, select the profile for which you want to show the dimensions. Yeah, so now I guess it is complete. This is for your cone and cylinder, and keep this in your mind that this is a solid of revolution that I will do. Before to that, let me finish the task by putting the name and exercise problem. Select these things, Control C, and come to your drawing number 3, Control V. This is name, roll number is common, and this will become 3. Control P for printout, plot, go to this PDF, paper size, you select A4, display, go to Windows, and select this as your Windows, center the plot and preview. Okay, so this is what you will get, and then you can plot it and save it. Uh, 3, save it. So this is what you will get for your problem number 3. So this printout you have to keep it in your record book. Okay, now coming back to your AutoCAD file, and from here what we can do is, uh, now it's 12:46, so we will see that today what we have seen. We will do a fast recap. Let me take annotation, and color is yellow. Okay, so first we have seen what are the solids. In solids we have seen two category. The first one is your polyhedra, and the second type that we have seen is your solid of revolution. In polyhedra, we have seen two types again. The first one is your prism, okay, and the second one that we have seen is your pyramid. In solid of revolution, you have seen cone and cylinder. Okay, so these things you keep in your mind, and as a whole, if you will see, today we have seen the projections, how to draw the projections for solid solid in simple position. Solids in simple position we have seen for prism, we have seen for cone, and we have seen for your cylinder. For pyramid it is left, that we will see in the next class. Two problems are left now. One is for your pyramid and another one is anyone, suppose prism or pyramid, inclined to one of the axis, inclined to any one of the axis, okay, and parallel to one of the plane. So this is all from my side. If you have any doubt, then you can ask me now. Session is open to all. Now we have 55 participants. Any doubt, you can ask me. If you have no doubt, you can type in the chat box, clear, sir. So the next class, when we will be having the next class, it will be on Tuesday, 2nd of February. Okay. So I guess one more session we will get, okay, online session. After that, your syllabus will also be complete and you will get ample time for practice in the lab. Okay. So on Tuesday, there will be, I guess, this one more online session. After that, you will practice in the lab. That's all from my side. If you have any doubt, any question, you can ask me, or else I will stop the meeting. Okay, so I guess everyone, it is clear to everyone. So have a nice day. Keep drawing, keep learning. I'm going to end the meeting.